Assalamualaikum warahmatullahi wabarakatuh. So in this video, we are finally going to discuss case number 3 in limits. We already have all the knowledge that we need for this case, the existence of limit and the concept of one-sided limit. Now let me introduce you to the third case here. As you know, to find limit, you just need to substitute the value of x. If after you substitute and then you got constant over 0, then that is our third case. For this case, your answer would be either positive infinity or negative infinity. And how to know which way they go? As you can guess from the flowchart here, we need to use the concept of one-sided limit. Let's see the explanation of that with an example. So let's go back to slide number 15. In this question, we want to find limit when x is approaching 0 for the function 1 over x. If we substitute the value x equals to 0 here, we are going to get 1 over 0, which is constant over 0, which is also our third case. So because of that, we need to find one-sided limit from both sides of 0. We need to find limit when x is approaching 0 from the left for the function 1 over x, and limit when x is approaching 0 from the right. Okay, let me show you a number line here with 0 in the middle. In the topic one-sided limit, we can just substitute the value of x here to find the limit. But we cannot do that here because when x is equal to 0, 1 over x is undefined. Since the concept of one-sided limit is to find the value of a function when x is really close to a number from the left, and in this case the number is 0, we are going to use the number from its left. So the integer before 0 here is negative 1. If we substitute x equals to negative 1, y would be negative 1. But the value x equals to negative 1 is not close enough to 0 from the left. So let's use another value of x that is closer than that. Say x equals to negative 0.1. And if we substitute x equals to negative 0.1, the value of y would be negative 10. But for limit, we need to get very close to 0 from the left. So let's use another value of x that is much more closer than negative 0.1. Let's take x equals to negative 0.01. And if x is equal to negative 0.01, y would be negative 100. Let's get even more close than that. When x is equals to negative 0.001, y would be negative 1000. And the pattern continues. We can see that the closer we get to 0 from the left, the value of y would get bigger and bigger in the negative direction. So our answer for limit when x is approaching 0 from the left for the function 1 over x is negative infinity. We have one more thing to find here, the limit from the right. Just like the limit from the left, let's use the number line here. The integer on the right of 0 is 1. And if we substitute the value of x equals to 1 into 1 over x, we are going to get y equals to 1. And as you've seen before this, 1 is not close enough to 0 from the right. Let's take x equals to 0.1. When x is equals to 0.1, the value of y is 10. And we know that even 0.1 is not close enough to 0 from its right. Let's take x equals to 0.01. Then our value of y is equals to 100. See, this follows the same pattern just like the limit from the left. As we get closer to 0 from the right, the value of y will get bigger and bigger, but this time in the positive direction. So, that makes our answer for limit when x is approaching 0 from the right is positive infinity. Now, recall back from the previous video on the existence of limit. On the left, the limit is negative infinity. And on the right here, the limit is positive infinity. When the limit from the left is not equal to the limit from the right, then the limit doesn't exist. So we need to write the reason and its conclusion just like in the previous video. Since limit when x is approaching 0 from the left for the function 1 over x is not equal to the limit when x is approaching 0 from the right for the same function 1 over x, therefore limit when x is approaching 0 for the function 1 over x does not exist. Okay, let's try something a bit more challenging than that. Relax, we can do this. First, we substitute to confirm our case. We want to find limit as x is approaching 2. So substitute 2 into the function here. So we got 4 over 0, which is constant over 0, and our third case. Now that we know that, we're going to find one-sided limit from both sides. Let's start from the left. Let's use the number line here to help us with this. We have 2 in the middle, and if we want to approach 2 from the left, the integer here is 1. And as we've seen from the previous example, this case can either be positive infinity or negative infinity. So we need to choose one value to confirm our answer. We need to choose a number that is very, very close to 2 from the left. Just one decimal place is enough this time. So here I'm going to use 1.9. When x is equals to 1.9, the value of y is equals to 390. Just a reminder here, do not put this in your calculation. The only thing that you should have here is either positive or negative infinity. Anyway, since we got a positive value here, we can write our answer as positive infinity. Now, I want to try to find the limit from the right. I'll hold the screen for 3 seconds and then I'll explain this again. Okay, since we want to approach from the right, the next integer here is 3. Now we need to choose a value close enough to 2 from the right to confirm our sign, whether positive or negative, and one decimal point is enough. So I choose 2.1 to substitute here. When x is equals to 2.1, y is equals to 410. And this is a positive value. So that means the limit from the right is positive infinity. Now, since limit when x is approaching 2 from the left is equal to limit when x is approaching 2 from the right. Therefore, limit when x is approaching 2 for this function is equals to positive infinity. So, this is the end of this chapter. Make sure to clear any misunderstanding in this chapter because you're going to use this again in the next chapter on the first principle of differentiation. So, I wish you all the best. Thank you for your attention. Have a great day. Take care and goodbye.